my YouTube channel ViewMaths. Today we are going to learn numerical solutions of algebraic and simultaneous equations. Under this topic we are going to learn two very important methods, Jacobis method and Gauss Siedel method. So if you are watching me first time, do subscribe my channel and click on the bell icon to get all notifications of my latest videos. So let's begin. Numerical solutions of algebraic and simultaneous equations. So there are mainly three methods. The first is Jacobis method, second is Gauss Siedel method, and third method is Gauss elimination method. But in this video we will be discussing only two methods, Jacobis method and Gauss Siedel method. I will make a separate video for Gauss elimination method. Let us start with the Jacobis method. Now the Jacobis method for solving linear and simultaneous equations will be explained by an example. Now look at the problem. Solve the following system of equations of Jacobis iteration method. Carry out 3 iterations only. Now these are the 3 equations given to you. With the help of these 3 equations, we have to find its solution. Okay. So let us focus on this. What we are supposed to do, we have to rewrite the equation. This is the most important part of the whole method. Now here basically the students commit a mistake. The equation which is given first, they are taking it first. The equation which comes second, they take it second. No, it is not like that. This is called as a pivoting of elements. Means we have to see the coefficients of x. What is the coefficient of x in first equation? 15. Second equation 2. Third equation 3. Which is the highest one? 15. So first equation will be the equation where the coefficient of x is highest. Okay. Now come over the remaining 2. First is fixed. Now in the remaining 2, where is y maximum? The y is maximum in second equation. So we are writing it as a second place. And then we have no option left. So third equation, the equation which is left is third equation. So now here in this problem, the equations were given in the same sequence. But in examination, it may be a different sequence. Maybe the highest x will be the third equation given in the paper. Then you have to make it a first equation. Okay. So coefficient, I repeat again. So first equation will be the equation where the coefficient of x is maximum. Second equation will be the equation where the coefficient of y is maximum. And the leftover is third one. Okay. Now we have to find x from the first, y from the second, and z from the third equation. How do we find it? First equation is 15x plus 2y plus z is equal to 18. So 2y and z both will be shifted to the right hand side. It will become negative. So it will become 18 minus 2y minus z is equal to 15x, and that 15 comes down here. In the same way, we find y from second equation and z from third equation. So we get these three, the values of x, y and z in terms of the other two variables. Okay. After this, we have to start. So we have to start with the trivial solution. What is this trivial solution? It's an initial solution. We can call it as an initial solution also. So we take x is equal to 0, y is equal to 0, z is equal to 0. Always. So this is called as a trivial solution. So instead of x, we'll write x naught. X naught is equal to 0, y naught is equal to 0, z naught is equal to 0. Now number of iterations. Number of iterations means number of steps to be repeated. So if you are doing particular steps in one iteration, the same steps is to be repeated in the second iteration, and it is repeated 3 times because it is asked in the question that you have to carry out 3 iterations. After 3 iterations, whatever is the answer, that will be your answer of this problem. Okay. So now let us start with the iteration. First iteration. What is the first iteration? N is equal to 1. I have written slightly tilted this way so that we can, this is a way of highlighting it. We are talking about the first iteration. N is equal to 1. In first iteration, we will get x1, y1, z1. In second iteration, we will get x2, y2, z2. And in third iteration, we will get x3, y3, z3. And x3, y3, z3 will be the final answer. Okay. Now, how to write this equation? Now see here. In this equation, this x, y and z, this side you will write 1, 1, 1, x1, y1, z1. And the right side you will write 0. Means just one number less. So 1 minus 1 is 0. So if this side is x1, y1, z1, right side will be 0, 0. If this side will be x2, y2, z2, the right side will be x1, y1, z1. If left side is x3, y3, z3, right side will be x2, y2, z2. One number less. Okay. So now coming to this first iteration, x1 is equal to 1 by 15, 18 minus 2y0 minus z0. Okay. So substituting the value of y0 and z0, both are 0, 0. So 18 minus 2 into 0 minus 0. So actually this part becomes 18. 18 divided by 15 and the answer is 1.2. Similarly, 1 by 20, 19 minus 2x0 plus 3z0. So x0 is 0, z0 is 0. So answer is 19 divided by 20 and that becomes 0.95. Similarly, we are putting the values here. x0 is 0, y0 is 0. So z1 will be 22 divided by 25 and this becomes 0.88. Okay. So for the second iteration, we are using these values x1, y1, z1. For x1, y1, z1, we have used the values x0, y0, z0. So the same way for x2, y2, z2, we'll be using these values x1, y1 and now the second iteration starts. N is equal to 2. So since page is changed, so we have already written the values x1, y1 and z1 here so that we should not miss it. If your page is changed in the answer book, then you also do the same way. Okay. This side becomes x2, y2, z2. The right side becomes x1, y1, z1 here in this part. Substituting the values y1 and z1 here, you can see 1 by 15, 18 minus 2 into y1, 0.95 minus z1, 0.88. And after calculating this, we are getting the answer 1.0146. x2. Now y2, 1 by 20, 19 minus 2x1 plus 3z1. Substituting the values of x1 and z1 here and calculating this part, we are getting 0.962. And similarly, z2 is calculated the same manner, substituting the values of x1 and y1, you can see here, and after calculating x1 and y1, the final answer for z2 is 0.964. Okay. Now moving to the third iteration and the final iteration. So x2, y2 and z2, the values are written over here because we are going to use it. This side is x3, y3, z3. This side will be x2, y2 and z2. Okay. Substituting y2 and z2 here. 18 minus 2 into 0.962 minus 0.964. And after calculating, we are getting 1.007. So y3 will be 1 by 20, 19 minus 2 into 1.0146 plus 3 into this. These are the values of x2 and z2, which is substituted here, calculated using calculator, and you get answer 0.9931. Similarly, for Z3 we'll substitute the values of X2 and Y2 here this way and calculate. You will get 0.9891. So 3 iterations are over. So we can directly write the answer. After 3 iterations, the solution is given by X3 is equal to 1.007, Y3 is equal to 0.9931 and Z3 is equal to 0.9891. Okay, this is the way we have to solve the Jacobis method. Now, why 3 iterations are given? Because 3 iterations are given in the problem, so we have done 3 iterations. If only 2 iterations are asked in the problem, then you have to solve only 2 iterations. So after n is equal to 2, your final answer will be x2, y2 and z2. If 2 iterations were asked in the... Now second method, Gauss Siedel method. So let this method also be explained with the help of an example. Solve the following system of equations using Gauss Siedel method. Carry out 3 iterations. So 3 equations are given to you. In the same manner, the first initial part is same up to trivial solution. Everything is same. So 3 equations are there. So where the coefficient of x is maximum, that will be the first equation. Here see 5x, x and 2x. Okay. So 5 is maximum. So this equation is made as first equation. Now in these 2 equations, because this is over, so these 2 equations 7y and minus y. So y is maximum here. So this becomes the second and the leftover becomes the third one. Okay, pivoting is done. Now we have to find the value of x from the first, y from the second and z from the third. The same manner as what we have find out in Jacobis method. Shifting y and z on the right side and bringing 5 down. Okay. The same manner we have calculated x, y and z. And then we start with the trivial solution. X naught is equal to 0, y naught is equal to 0 and z naught is equal to 0. There is a slight difference in Jacobis and Gauss Siedel. I'll let you know. Now coming to numerical solutions of algebraic equations. The second method is Gauss Siedel method. Let this method also be explained with the help of an example. Now second method is Gauss Siedel method. Let this method also be explained with the help of an example. So example 2. Solve the following system of equations using Gauss Siedel method. Carry out 3 iterations clearly specified here. Now 3 equations are given to you. Okay. How you will do it? The same way. We have to do the pivoting of elements. So we have to identify where x is maximum. See. The coefficient of x is 5, coefficient of x is 1, coefficient of x is 2. So this equation becomes the first equation. Now in the leftover, the 7y and minus y. So it is 1 and here it is 7. So this equation is going to be the second. And anyway, the third equation will be the leftover. So we can see that 3 equations are identified. Now we have to find the x from the first equation, y from the second equation and z from the third equation. It's the same way as what we applied in Jacobis method. How do we calculate x from here? Shifting y and z to the right side and bringing 5 down. Okay. Here calculate y, x and minus 3z will be shifted to other side and then 7 will come down. Similarly z also. So find out the value of x, y, z. After that, we have to start the solution. So let us start with the trivial solution. What is this trivial solution? Now you know it is x naught is 0, y naught is 0 and z naught is 0. This is also known as initial solution. Okay. Let us start with the first iteration n is equal to 1. x1 is equal to 1 by 5. Now this side is 1, the other side is 0. So 18 plus 2 y naught minus 3 z naught. Okay. Substitute y naught is 0, z naught is 0. So x1 is equal to 18 divided by 5, which is equal to 3.6. Now up to x1, the method of the Jacobis and Gauss Siedel is same, exactly same. So why this is a different method? Because the difference start at y1. What is the difference? In Jacobis method, we were considering the old values. For example, x naught, y naught and z naught all are 0. So these values are fixed for the complete iteration n is equal to 1. But in case of a Gauss Siedel, we are taking the latest values. Suppose x1 is now calculated. Now we know x1 3.6. Once x1 is available, we will not consider x0. x0 is the old value. x1 is the new values or the latest value. So latest value will be considered. That is the only difference between Jacobis and Gauss Siedel. In Jacobis, we are taking old values. In Gauss Siedel, we are taking the latest values. So x1 is equal to 3.6. So for calculating y1, we are substituting x1 and not x0. In Jacobis, it was x0 here. But in Gauss Siedel, it will be x1. But z1 is not available, so we are considering z0 only. So z0 is equal to 0 and x1 is 3.6. It is substituted and y1 is calculated as 2.6285. Now x1 is known to you, y1 is known to you. That means x0 and y0 are the old values, they will not be considered. So for z1, we will be considering x1 and y1. Substituting x1 here, y1 here, and we are calculating, getting the answer as 2.9047. The same thing which I have just explained is given as a note here. In Gauss Siedel method, we are taking latest values. Now coming over, n is equal to 2, the second iteration. So x1, y1 and z1 values are already written over. This side is x2. Okay. So this side will be x1, y1, y1 and z1. We have substituted y1 here, z1 here. Okay. So initially we know only x1, y1 and z1. So we'll be using these three values. Now once x2 is calculated, x1 is out of the picture now. For further calculations, we'll be using x2, y1 and z1. Okay. So in y2, we are substituting x2 here, but z1 here only. So the value of x2, which is 2.9085, will be substituted here. You can see. And plus 3 z1. z1 is given here. So this is substituted. And calculate this part. It comes as 3.9722. 9722. Now x2 and y2 are known to you. So in z2, we'll be using x2 and y2. x1 and y1 are out of the picture now. So 1 by 6. 22 minus 2 into x2 is 2.9085 plus y2 plus 3.9722, which comes out to be 3.3592. So this way we have calculated x2, y2 and z2. Now moving to the third iteration, x2, y2 and z2, the values are given. Calculate x3, this side will be x3 and this side will be y2 and z2. Substitute y2 and z2 here. We are getting the values as 3.1733. Now once x3 is calculated, x2 will not be considered. x2 becomes the old value now. So for y3 we are putting x3 here but z2. Okay, substituting these values and calculate it, we are getting 4.1291. And Now x3 and y3 are already calculated, so x2 y2 will be out of the picture. Let us use x3 and y3 here. Substitute the values of x3 and y3 and calculate the entire part, and the value comes out to be 3.2970, which is the value of z3. Now 3 iterations are over and we are asked to complete the problem with 3 iterations only. So after 3 iterations we can directly write down the solution as, after 3 iterations the solution is given by x3 is equal to 3.1733, y3 is equal to 4.1291, z3 is equal to 3.2970. It's the same values, you can see. This will be the final answer and your problem is over. Okay. Now I have clearly mentioned the difference between the two. Students normally get confused. They apply Jacobis method in Gauss Siedel and Gauss Siedel method in Jacobis. So they are taking, you remember, in Jacobis method we are taking old values of x, y, z. In Gauss Siedel we are taking the latest value. Okay. Now we have done one problem where the Jacobi, which is solved by Jacobis method, the same problem is solved by Gauss Siedel method, and that too on one page only, so that you can clearly see the difference in the two methods. Now see this. Example 3. Solve the following system of equations by Jacobis and Gauss Siedel method. Only 2 iterations. Why 2 iterations are taken? Because we just want to illustrate the difference in both the methods actually. Okay. Now Jacobis method, here in this part we are solving by Jacobis method, and the right side I am solving it by Gauss Siedel method. Now focus on this. See the steps. Rewriting. X is highest, same way. Y, the highest coefficient of y, and then we taken it as second equation and third equation the same way. Okay. See, both are same, both sides, everything is same. Let us start with the trivial solution. X0 is 0, y0 is 0, z0 is 0. Here also same. There's no difference at all. This part is common to both. Then n is equal to 1, x1. Here we write y0, z0. Here also we write y0, z0 because we have only those latest values only. So what is x1? 0.4. Here also x1 is 0.4. Up to x1 you can see that Jacobis and Gauss Siedel are same. Up to first iteration of x1 only. Now when y1 starts, here we are taking old value. See, x0, but there x1 is available. It is calculated 0.4. So x0 will not come into the picture. So we are using x1. That is the difference. Notice. In Jacobis, this is x0 only, old value. But here in Gauss Siedel, this is latest value. Understood? So we calculate, substitute the values and calculate, we get the answer 1.92. And see here the answer is 2. The difference comes. Again, in Jacobis, we are taking the old values only. Now here, y1 is also known to you. Now you can see here we are taking x0 and y0. But here the latest values are available as x1, y1. So we are substituting x1 and y1. And substituting the values and calculating the answer. Okay. Moving to the next iteration 2, you can see that when you write x2, y2, z2, the right side will be writing y1, x1, y1 and z1. Okay. For Jacobis, old values. And here x2 will be same. But for y2, this is x2 now. And here this is x1. So I just marked it by red so that you can identify, you can clearly see the difference in the two. And here it is old value x1, y1, but here it is the latest value available x2, y2. So after 2 iterations, by Jacobis method, we can get the answer like this. By Gauss Siedel method, we can get the answer like this. Gauss Siedel method is more accurate than Jacobis method. Means the order of error in Gauss Siedel is lesser than the order of error of Jacobis method. Okay. Dear students, Jacobis and Gauss Siedel method are explained with the help of examples. Hope you would have understood both the methods and the difference between both the methods very well. If so, do share and like the videos. Thanks for watching. Stay connected.